two propositions regarding the efficiency of a CARNOT cycle. There are two important propositions regarding to the efficiency of CARNOT cycle. The first one is there are two propositions regarding the efficiency of a CARNOT cycle. The first proposition it is impossible to construct an engine that operates between two given reservoirs. It is impossible to construct an engine that operates between two given reservoirs and is more efficient than a reversible engine operating between the same two between the same two it say that the maximum efficiency is for a reversible engine. The proof of this statement is provided by a thought experiment. An initial assumption is made, and it is then shown that this assumption leads to impossible conclusion. The only possible conclusion is that the initial assumption was incorrect. Let us assume that there are an reversible engine between two given reservoirs as shown in this picture. consider this picture for first proposition. Let us assume that there is an irreversible engine operating between two given reservoirs that has a greater efficiency than a reversible engine operating between the same two reservoirs. Let the heat transfer to the irreversible engine QH as shown here, and also for the irreversible engine we have QH from a high temperature engine to the irreversible engine, and the heat rejected PQ prime N to the low temperature reserve, and the work B is Q for irreversible engine, W irreversible engine equal to QH minus Q prime N, and W reversible QH minus QN according to these quantities. Let the reversible engine operate as a refrigerator in this case. Finally, let the transfer with the low temperature reservoir be QL as shown here. The heat transfer with the high temperature reservoir is QH, and the work required is this quantity. Since the initial assumption was that irreversible engine is more efficient, it follows that assumption irreversible engine more efficient than reversible engine. So we have these quantities. Let's say that with us, if we QL should be greater than Q prime N. It means that the Q prime N is lower and the heat losses is lower in this case, and for that the QL greater than Q prime N, and the work of irreversible engine greater than work reversible. Now the irreversible engine can drive the reversible engine and still deliver the net work. W net for the reversible action of irreversible process engine in this equals to Q L minus Q prime L. If we consider that this is the two engine and the high temperature reservoir as indicated in the picture, we have a system that operates in a cycle, exchange heat with a single reservoir, and does a certain amount of work. However, this would constitute a violation of the second law. We calculate that our initial assumption is incorrect, therefore we cannot have an irreversible engine that is more efficient than a reversible engine operates between the two same reservoirs. For more description, this system, if we consider this control system for a control volume, in this case it say that we have work here, that will be net, that comes from exchanging heat from the low temperature reservoir, which is violates the second law.